All right, 2.7 we were working on last time, and we had encountered this idea of taking derivatives where the y is not solved for. And we had one more problem that we were working on, question number 6. And on question number 6, we are asked to find a second derivative. So in order to find a second derivative, we obviously have to find a first derivative, you bet. All right, so let's do that part first. That's not going to be any different than what we've done before, except that our function, of course, looks a little bit different. So what is the derivative of x to the 2/3? Excellent. You guys are right on target today. All right, so that piece is like we've been working on for a couple of weeks now. Now I've got a y to the 2/3. What will that one look like? Okay, so the first part of that looks exactly like the x part, and then what do I need? Y prime, because it's really a chain rule, right? And this equals what? It does. Very good. All right, so we've talked about on the last problem, just let me remind you on this particular one, we were actually asked to find on problem number 5, actually 4 is the one I was thinking of. On problem number 4, we were asked to find the tangent line, and we talked about making sure that when we were asked certain questions that we answer the questions that are asked. And so on this one, because we were given these input value of 2 and pi-3, we might not actually have to solve it for y prime directly, at least in a general sense. We could actually plug the numbers in and solve. Well, on this one, although it doesn't tell us to do so, we do need to solve it for y prime. Why? So I can find the second derivative, right? So it's sort of that intermediate step. We are going to simplify this, and we do want to simplify this as much as possible, kind of in the same way that I was talking about the one that I have on the board, right? If I'm trying to take another derivative, and I'm going to do that, then I'd like to have the information simplified as much as I can beforehand, because it's going to make that next derivative easier to work with. All right, so we are going to solve this for y prime. So the first thing we might want to do is to move that 2/3 x to the 1/3 to the other side, right? X to the negative 1/3. All right, so I have 2/3 y to the negative 1/3 y prime equals negative 2/3 y to the negative, x to the negative 1/3. All right, there's one thing I can simplify really quickly. The 2/3, it's on both sides, right? So whether you think about just removing it or we were thinking about multiplying by the reciprocal, if you do it to both sides, it's going to eliminate it, right? Multiply by 3/2 on both sides, it's not going to be there any longer. So that's kind of nice because I don't have the coefficient anymore. What's next? Okay, so let's divide by the y to the 1/3. Negative 1/3, yes, thank you. All right, so y prime is going to equal negative x to the negative 1/3 over y to the negative 1/3. And while I could work with it like this, and it would be okay and it wouldn't be awful, I also could do one more simplification step that I might be more friendly to work with. What could I do? Say that again for me, Ben. You can't bring out a power, but it is about the powers that we'd like to simplify. We could flip it, right? Because they're both negative, we could actually flip the fraction upside down. It's a property of exponents that would allow us to write this in a different way. So I could write this as y to the, and it's negative still, put the negative somewhere, y to the 1/3 over x to the 1/3. And I'm going to actually do one more step, and it's not something you would have to do, but because I think it makes the derivative cleaner, I'm going to do it. I'm going to write this way. And that might be where you were headed, Ben, when you were saying factor something out. I'm not sure. I'm actually going to pull that 1/3 out. There's a property of exponents, write it as a power on the outside of that. And it doesn't really matter in the sense that you can work with it either way. If you choose to leave it with the 1/3 on the exponent on the top and the bottom, you're going to be using a quotient rule, right? And inside of the quotient rule, the numerator is going to have a chain rule because this is y to the 1/3. If you decide to pull it out like this, you're going to have a chain rule because you've got a power of 1/3 on the outside. And inside of here, you're going to have a quotient rule. So it's just really which order you want to work with it. I like doing it with the 1/3 on the outside because then the derivative of the inside is going to be really clean because I don't have any exponents on it. So when I'm working on the derivative of the chain rule on the inside, or the quotient rule on the inside, it's going to be a very clean inside derivative. All right, so this is what we've got so far. I've got y prime equals negative y over x to the 1/3. Okay, is that good so far? That's where we are? I rewrote it okay? All right. All right, second derivative then. The negative is still there, but I'm going to pull the 1/3 down because it's a chain rule and rewrite. So far, so good. Because it had an exponent originally, I need to take that exponent and do what? Subtract 1. And what will 1/3 minus 1 be? Negative 2/3. Good. Now I need the derivative of what is inside. That is, it is a quotient rule. So the quotient rule here says I'm going to do the first, or do the denominator times the derivative of the numerator, which is what? Y prime or dy dx. Minus the numerator, which is y, times 1. You can write it or not. We're eventually going to drop it anyway. Over x squared. Okay, pretty good with that?
Where did the one come from? Oh,
The
that's
derivative of the denominator.
Okay.
Yep. Any other questions? Okay, we are going to clean this up. Right now I've got x's and y's sort of all over the place, don't I? And I would like to consolidate them as much as possible, clean them up as much as I can. So right now I've got the negative on the outside of the function. In fact, I'll put it in the numerator because I'm going to do it somewhere anyway. And this is y to the negative 2/3 on top. I have x, I've got a 3, and then I've got x to the negative 2/3 on bottom. And then I've also got an x squared on bottom from the other function, right? The other, not function, but the other factor over here from the quotient rule. And then on top I have x y prime minus y. So some pieces of this simplify. That that denominator right now, that simplifies right now, doesn't it? We've got x to the negative 2/3 and x squared. So what will that give me? 3 is still there. X to the negative. X to the 4/3. So how do we get 4/3? A couple of you said it.
If you think about it, it's just 6/3.
You add them together, and Taylor's telling me you think about the two as 6/3, right? So negative 2/3 plus 6/3 is 4/3. Very good. Now, on the numerator, I'm going to distribute this. And so I have x, y to the negative. You know what? Actually, I don't want to distribute. Let me do something different. How about I move that y to the negative 2/3 to the denominator? Are you guys good with that? You like that all right? I can do that because it's a factor, and I've got to move it to the denominator to become a positive exponent. That's a little bit friendlier. X to the y prime minus y.
The negative always stays on top no matter what.
It wouldn't have to, and that's actually not negative down the middle. It's actually positive. You could put it in the denominator if you wanted to. I chose to put it in the numerator. The negative that was in front. Is that what you're asking me, Taylor? Okay. And I needed to distribute it because it does have a negative effect on a change effect on the inside of the parentheses. There's something I need to do, though, that I haven't seen done before. I've got a y prime in the middle of it on the right, right? The right side has x, y, and y prime as sort of 3 different variables over there. But I know what y prime is. What's y prime? Yeah, it's that original piece at the very top of the screen, right? The negative business over here going on. And as I take a look at that, some of that can simplify. I could actually put the 1/3 back on the top and the bottom. So let's actually take this piece here, and we're going to plug it in right here. All right, so I've got that negative on top, and I've got the x, and then I've got another negative of y to the 1/3 over x to the 1/3. And then I have plus the y, that's the original numerator from the previous step. And then the 3x to the 4/3, y to the 2/3. All right, quick step, easy thing. What can I do? What's the cookie? How about the negatives first? That's actually easier. But we are going to get rid of the x's after that. So if you notice, you've actually got x to the 1 out here. I don't mean prime, I do mean the number 1. This is x to the 1 power, and this is x to the 1/3. So you can actually take this 1 minus this 1/3, because this one's in essence in the numerator, this one's in the denominator. So this would actually give me what? X to the 2/3. So I'm running out of space down here. So I've got x to the 2/3, y to the 1/3, and then I have plus a y, yeah? And then my denominator is 3x to the 4/3, y to the 2/3. There's one tiny little bitty step that I can do still to simplify this. I have a y in every term, don't I, Ben? I do, and they don't all have the same exponent, but there is a y in every single one of them. Does everybody see those? What's the biggest exponent? I'm sorry, what's the smallest exponent they all have? The y to the 1/3 is the smallest exponent. So what I can actually do is I can do a division, right? I can divide or reduce, simplify, whatever you want to use the word for. I can simplify each of them by that exponent of y. That is, I can divide each of these by y to the 1/3. Now, dividing by y to the 1/3 is equivalent to subtracting that exponent of 1/3, because that's a property of exponents. So the x to the 2/3, that stays. Now I have a y to the 1/3 divided by y to the 1/3, so that piece is gone, right? It's 1. It's equal to the number 1, so that's not going to be there anymore. I had a y divided now to the y to the 1/3 by the y to the 1/3. So what will this piece over here be? That'll be y to the 2/3. My denominator still has a 3x to the 4/3 in it. Sorry, my exponents are really tiny, so they're really hard to read. Not even sure that looks like a 2, but that's a little bit better. And the denominator now I have y to the 2/3 divided by y to the 1/3, so that is y to the 1/3. Remember, you're subtracting exponents, so 2/3 minus 1/3 is 1/3. And lo and behold, you are finished, because there's nothing else you can reduce. Yay. They're messy, right? And they're not always as messy as some other piece. I mean, they don't all have this feature where we get them real complicated with the exponents. But they all have different features that do make them messy. They all will at some point have that y prime in them that you have to substitute back in when you're working with finding a second derivative. That's a common feature.